Hello everybody, this is proving lines are parallel. All right, so what we're going to be talking about here is instead of working with, okay, so in the last lesson, we started with, okay, if two lines are parallel, then you're given these special angle relationships. And in this one, what we're going to prove is because these special angle relationships are congruent, so we're talking about corresponding, alternate interior angles, alternate exterior angles, okay? If you get some congruency with those special angle pair relationships, then the lines are also parallel, okay? So we're going to be working backwards. So there's a logic statement, right? It says if P, then Q, right? And if you were to write that, it would look something like this. The converse of that logic statement, and now we're not going to be talking about logic statements, so don't worry, but the converse of that is if Q, then P. So the Q starts first, and then, if Q, then P happens, right? So what does that all mean? Why am I even taking the time to explain this? Well, let's talk about the corresponding angles postulate. It says if two parallel lines are cut by a transversal, then their corresponding angles are congruent. Okay, so that was what this statement said in the last unit. The converse of that means we're going to take this statement and we're going to flip it right around. So in this case, picture this as P, then Q. Down here is Q, then P, right? We're stating if two lines cut by a transversal so that the corresponding angles are congruent, then the two lines are parallel. Okay, and so what we're looking for if this, or if this, or if this, or if this happens to be true, okay, so four different options there, then A is parallel with B. Okay, so what you're looking for again is your corresponding, so 1 and 3, all right, 2 and 4, 5 and 6, and 7, and, 5 and 7, 6 and 8, my bad, whoa, 5 and 7, then 6 and 8. I don't even know what I just said there. Yeah, 1 and 3, 2 and 4, 5 and 7, 6 and 8. Okay, so those are our corresponding angle pairs. So what we're going to say is if those corresponding angles are congruent, then the two lines are parallel. That's one of them. Another example, there's 4 more here, all right? If the alternate exterior angles are congruent, so you got 1 and 3, let's say this is 2 and 4, okay? If 2 and 4 are congruent, then P is parallel with Q, okay? Or in this case, they got 1 and 3 there, right? Our consecutive interior angles, what that states is if the angle 4 and angle 5 add up to 180 degrees, then based off this consecutive interior angles converse postulate or theorem, then P is parallel with Q. Okay. Or also, if you had angle 1 and 2, you could also use those as well. So if angle 1 is congruent with angle 2, then, then P is parallel with Q. Okay? Our alternate interior angles converse, kind of just like the alternate exterior. All right, so let me put some different numbers in there, 4 and 5. All right, so what this is saying here, blah, 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 two lines cut by transversal so that their alternate interior angles is congruent, then the lines are parallel. So if 6 and 8 are congruent, or if 4 and, angle 4 is congruent with angle 5, then again, P is parallel with Q. All right, and then finally, perpendicular transversal converse. What it's saying here is if P, line P, all right, is perpendicular with R, and line Q is perpendicular with R, then P is parallel with Q, right? Which makes sense because if we have a line and this one creates a 90-degree angle and this one creates a 90-degree angle, right? We know that those two lines have the same slope, right? Because you got to be kind of special to make a nice perpendicular line. Remember, the slopes of perpendicular lines are negative reciprocals. Okay? Let's get into some problems here. All right, so given the following information, determine which lines, if any, are parallel. State the postulate or theorem that justifies your answer. Okay, so we're just going to follow along what they did. So they started out 1 is congruent with 6. Okay, well, we know that 1 and 6 are alternate exterior angles, and because those two are congruent, then this line and this line are parallel. Notice I didn't say anything about M, okay, because neither one of those angles are attached with M. Okay, so we can't say anything about M, but we can say L is parallel with N because 1 and 6 are alternate exterior angles, and by the converse of the alternate exterior angles theorem, those two, or the lines are parallel. All right, let's take a look at letter B. Right, in letter B, they said 2 and 3 are congruent. If you look at 2 and 3, these are alternate interior angles. Okay, they are inside lines L and M. So because 2 is congruent with 3, L is parallel with M by the converse of the alternate interior angles theorem. Okay, so let's keep going here. Let's talk about angle 2 and angle 8. So angle 2 and angle 8, right? Well, let's see what lines are they really associated with. Well, they're both touching A and B, right? So if those two lines, so what kind of relationship do those two angles have? Okay, those are alternate interior. Okay, by the converse of the alternate interior angle, or alternate interior angles theorem. Okay, now we got to come up with which two lines are parallel. All right, so we can't say anything about M because neither one of those guys are touching line M, so therefore our two lines that are parallel are going to be A and B. All right, now I'm not going to write out a whole lot of this, right, like they did up there. Okay, I'll just put their angle relationship, and by that relationship, these are the lines that are parallel. Okay, so let's take a look at 12 and 14. 12 and 14. Okay, looks like they're touching A and B in line M. All right, so what that means is that if those two angles are congruent, then by we'll call it the alternate exterior angles. Okay. Let me write this out over here so you guys can see this. A is parallel with B, and in this case again, A is parallel with B. Okay? Because we're not even touching our line L, so we can't say anything about it. All right, how about 8 and 13? All right, well, 8 and 13 fall in the interior of lines L and M, and they're both touching line B. So they are what we call consecutive interior angles. Okay, and so because they're consecutive interior angles and add up to 180, therefore L is parallel with them. Can't say anything about A because A is kind of left out of the question there. All right, how about 3 and 11? Okay, well those look like they are corresponding angles. And so therefore, line L is parallel with line M. Can't say anything about B because B's not even being used here. Okay, let's take a look at 1 and 15. This is where it gets a little tricky. Okay, if 1 and 15 are congruent, well, let's take a look at what lines they are touching. All right, angle 1 is touching lines L and A, and angle 15 is touching lines B and M. So therefore, if those two things are congruent, what we can honestly say here then is that lines L is parallel with M, and line A is parallel with B because they are alternate exterior angles. All right, and then finally 6 and 8. Okay, they look like, kind of look like vertical angles, right? So can I say anything about that then? I can't. All right, 8 and 6 are congruent. All right, well that just means they're vertical angles. All right, but we would need something where it's either 6 and 14, all right, or 6 and 16. Okay, those two angle relationships, okay, would let us know that these two things are parallel, or whatever lines are parallel. But because 6 and 8, okay, are just vertical angles, then we get nothing. Okay? All right. Let's get down to the nitty-gritty. So let's add some algebra to these guys. All right? So find x so that M and N are parallel. Okay? Identify the postulate or theorem you used. Okay? So think about these things as just numbers here, guys. Okay? They're just degree measures. All right? We don't know what x is, but if we certainly had a value for x, we could plug it in and find it out. All right? But we don't. And so we're just going to go by what relationship those two angles have in order to find x. And they are alternate exterior angles. So therefore, in order to show that M is parallel with N, right, we have to have the same value here as we do here. Right? We have to have the same angle measure. So in order to do that, I have to set these two things equal to each other. Okay? And hopefully I get a value for x that I could plug in for both, and so that both of them have the same angle measure. So I'm going to subtract 2x, get 2x minus 23 is equal to 17, plus 23 plus 23, you get 2x is equal to 40, divided by 2, x is equal to 20. All right, let's plug it in up here. We got 4 times 20, which is 80, okay, minus 20 will give me a 57. All right, it doesn't look like 57 degrees, but again, this is just the picture here. All right, sometimes geometry, they don't give you the right image. They want you to use the laws and the rules that we've set forth. All right, and so I'm going to plug this in for here. So 2 times 20 is 40, plus 17 is 57. So I get the same angle measure for each. All right, so again, all I did there was just use the fact that these are alternate exterior angles, and I was just trying to find what value can I plug in for both expressions in order to get the same angle measure for each. Okay? Now again, it doesn't match up. It doesn't look like 57 degrees, but just play along. Okay? And finally, find y so that E is parallel with F. Show your work. All right, well, it looks like E is perpendicular with this guy. All right, it creates a nice 90-degree angle, so that means this is also 90 degrees, this is 90 degrees, and this is 90 degrees. All right, and so what we're looking at here is I need to find something to set this equal to, right? And so I'm going to take a look at this angle here and this angle here. All right, so in this case, these are alternate exterior angles. Okay, they're alternate exterior angles, which means, all right, in order for these two things to have, in order for these two lines to be parallel, these two angle measures have to be the same. So I'm going to have to set 4y plus 10 equal to 90. All right, so I need to figure out what do I got to plug in there for y such that I get a 90-degree angle there. So I subtract 10, I get 4y is equal to 80. Divide by 4, y is equal to, same thing. That's kind of weird. How about that? All right, so I plug that back in. Let's see, 4 times 20 is 80, plus 10 is 90, and so all is good in the hood there. Okay, so we've just used these angle pair relationships, right, based off of their congruency to prove that lines are parallel. So we're kind of working backwards. All right, guys, good luck. And the rest is for homework, okay? We got just a handful of problems there, okay? So good luck, you guys.